In April 2019, humanity saw the impossible, a photograph of something that traps light itself. For decades, black holes were just mathematical nightmares, Einstein's equations gone wild. Scientists argued whether they were real or just theoretical curiosities. But now, we've photographed one. We've heard them collide. We've watched stars orbit invisible monsters at the center of our galaxy. Yet here's the terrifying truth. We still don't know if what we're seeing is actually what we think it is. What if black holes aren't holes at all? What if the event horizon, that point of no return, doesn't even exist? What if everything we think we know is wrong? Today, we're diving into 6 mysteries that keep the world's brightest physicists awake at night. Because when it comes to black holes, the more we discover, the less we understand. So buckle up. This journey goes deeper than the cosmic abyss itself. Let's start with the crisis that's been haunting physics for 50 years. Imagine you throw a book into a black hole. That book contains information, every word, every atom, every quantum state. According to Einstein, that information is gone forever, crushed into the singularity. But here's the problem: quantum mechanics, the other pillar of modern physics, says information can never be destroyed. Never, not even in a black hole. This is the information paradox, and it's not just academic hair-splitting. If information can be destroyed, then the universe doesn't make sense. Cause and effect break down. The laws of physics fall apart. Stephen Hawking spent decades on this. In the 1970s, he discovered that black holes actually evaporate through something called Hawking radiation. But this radiation appears to be completely random. It carries no information about what fell in. The information seems genuinely lost. Then, in his final years, Hawking proposed something radical. Maybe information gets stored in a fuzzy quantum layer around the event horizon, what he called soft hair. In 2020, a team of physicists made a breakthrough with something called entanglement islands, showing that information might actually escape through Hawking radiation after all, just in ways we can barely comprehend. But here's where we're stuck. We can't observe what actually happens at the event horizon. We're working purely with mathematical theories. Until we develop a complete theory of quantum gravity, merging Einstein's relativity with quantum mechanics, this paradox remains unsolved. And without that theory, we can't say for certain what black holes really are. Now let's talk about what's supposedly inside. According to the math, at the heart of every black hole is a singularity, a point of infinite density where space and time break down completely. All the matter that ever fell in, compressed to literally zero volume. Infinite gravity, infinite curvature, everything goes to infinity. But here's what physicists know. Whenever infinity shows up in your equations, it's usually nature's way of saying your theory is broken. It's like getting an error message from the universe. So what's really there? That's the mystery. Some researchers working on loop quantum gravity suggest that singularities might not exist at all. Instead, there could be something called a Planck star, an ultra-dense but finite object about 10 to the negative 35th meters across. When matter collapses, quantum effects might halt the collapse just before reaching infinity. Others propose gravastars, gravitational vacuum stars, where the interior is a bubble of exotic energy instead of a singularity. Some wild theories even suggest black holes might contain entire universes or wormholes to other regions of space-time. The frustrating reality? We have no way to check. To see what's inside, you'd have to cross the event horizon, a one-way trip. And even if you tried, the tidal forces would tear you apart atom by atom long before you reached the center. Your instruments would be shredded. Your data could never get back out. We're essentially trying to understand something that's hidden behind a cosmic censorship wall. Nature has sealed it off from observation. Now let's zoom out to one of cosmology's biggest questions: dark matter. We know it exists. We see its gravitational effects everywhere. It holds galaxies together, bends light, shapes the cosmic web. But after decades of searching, we've never detected a dark matter particle. Not once. What if we've been looking for the wrong thing? What if dark matter isn't particles at all, but black holes? Not the black holes from dead stars, These would be primordial black holes formed in the first fraction of a second after the Big Bang. When the universe was unimaginably hot and dense, random quantum fluctuations could have created pockets of matter so dense they collapsed directly into black holes. Some could be as small as atoms, others as massive as planets. The James Webb Space Telescope has thrown fuel on this fire. In 2023 and 2024, it found strange objects in the early universe that some researchers think might be primordial black holes. We're also analyzing gravitational wave data from LIGO and Virgo to see if any black hole mergers have the signature of primordial origins. Here's what makes this so tantalizing. If primordial black holes make up even a fraction of dark matter, it would solve multiple mysteries at once. No need for exotic particles, no need to invent new physics, just gravity doing what gravity does. But we're hitting walls. Any primordial black holes smaller than a mountain would have evaporated by now through Hawking radiation. Larger ones are incredibly hard to detect. They're black holes, after all. They don't emit light. We can only find them through gravitational lensing when they pass in front of distant stars and bend the light, or through their gravitational effects on other objects. Current surveys are searching, but the universe is vast and these objects could be anywhere. We need the next generation of telescopes and more sensitive gravitational wave detectors to settle this question. So, do black holes exist? Yes. The evidence is overwhelming. We've photographed them. We've heard them collide through gravitational waves. We've watched stars orbit them at the center of our galaxy. Their existence is not in question. But what they are, that's still one of the deepest mysteries in science. We don't know if singularities are real or if they're replaced by something else. We don't know if event horizons truly exist or if they're quantum firewalls or fuzzballs. We don't know where information goes. We don't know if they could be dark matter. We don't know how the supermassive ones formed so fast. And we don't know if nature's cosmic censorship law can be violated. Every answer we find spawns 10 new questions. Black holes sit at the intersection of quantum mechanics and gravity, the two pillars of modern physics that refuse to work together. They might be the universe's way of telling us our understanding of reality is fundamentally incomplete. And perhaps that's the most exciting part. We're living in the golden age of black hole discovery. Every new observation, every gravitational wave detection, every telescope image brings us closer to understanding these cosmic enigmas. The mysteries are profound, but so is our determination to solve them. The universe is hiding its deepest secrets inside black holes.